Hello everyone, my name is Carl Groover, and I've seen a lot of confusion on the purpose and various steps of burns required to put a satellite into orbit. So today I want to talk about the purpose behind the burns and coast phases, and hopefully some of you will find this helpful. In this case, I'm going to do a launch to GEO Sync because it is the most complicated case. However, the steps are very similar for nearly any launch. Launches in the U.S. from both the Cape and Vandenberg are launched from a point high above the equator. This makes it so that even if you launch due east, you will still have an inclination equal to how far the pad is from the equator. Stock KSP, the launch complex, is on the equator, so to simulate that, I am launching slightly north to add some inclination. Now, when launching out of the Cape, a rocket must travel 90 degrees around the Earth before it crosses the equator. This is true for any launch, though, regardless of inclination. It always takes the same amount of time at a given altitude and the same 90-degree point relative to where you started to cross the equator. So, why are we interested in how long it takes to get to the equator? Well, in this case, since we're going to an equatorial orbit, we need to do our burn on the equator so that the top point, or the apoapsis, of our transfer orbit actually aligns with the intended equatorial orbit. Now notice, as I move this around on our orbit that has a lot of inclination, you'll see the planes don't line up and the top point is very far off of the equatorial orbit we want to end up in. And if you were to do that burn, even though you did get up to the proper altitude, you would not be in the same plane. So, that's why we have a coast phase down to the equator so that we can burn the apoapsis up directly to the intended orbit. You notice at this point we're not doing any inclination change. And the reason for that is we're still traveling very fast because we're close to Kerbin. In order to get a more efficient inclination change, we want to coast all the way up to the top. And now that the satellite has been deployed, it's actually going to be responsible for not only circularizing, but also doing the inclination change itself. Now, if you'll notice, we burned the apoapsis up pretty far past the intended orbit. And that actually makes it does a couple of things. It also makes it cheaper for the satellite in terms of how much fuel it needs to do the inclination change. And it makes it cheaper to do the circularization for the satellite. Remember, there may be some extra fuel in the last stage on the rocket, but since the second stage on the Falcon 9 in this example cannot help with the circularization, it can only give you a higher transfer burn. So, in that case, that's what is done. And SpaceX regularly pushes satellites even double the height of a geosynchronous orbit. From this point, it is up to the satellite to finish getting to the desired orbit. Most satellites have very high efficiency engines, but they're also very low thrust. This means it takes a long time to finish the required burns. The amount of time on a geosynchronous orbit is greatly extended also because it takes several hours to get around to the apoapsis where you have to do the burn. These series of burns include the inclination change and circularization together so that they're much more efficient. Now, one interesting thing for you as we finish this up is that all Falcon 9 upper stages that have deployed satellites into a geo transfer orbit are actually still in that transfer orbit. Because the orbit only degrades when the periapsis is actually down in the upper atmosphere, then that means a very small percentage of the time is spent slowing down, so they are projected to be up as long as 100 years. Well, I hope you guys have found this interesting. Hopefully I've been informative on this and haven't made any terrible mistakes. I certainly enjoyed making the video. And if there's anything else that you have questions about or you would like explained, please do let me know. I definitely enjoy talking about it. So until next time, I am Carl Groover, and have a good one.